Hey guys, welcome back to Learn Python the Hard Way. In this exercise, we're going to focus on some review and we're going to take a look at some symbols. So in the previous exercises, we have already worked with a number of different keywords, some Boolean expressions and other pieces of code. And today in exercise 37, we're going to review part of that. And as always, you can find the link to the current exercise in the description below. This is part of the paid section of the book, so you'd need to purchase the book. Alternatively, of course, feel free to just work along and with this video. So first of all, let's take a look at some of the keywords. And ideally, we would write them out just to get more familiar with them. So if we take a look, for example, the AND keyword is one of the keywords we already used before. We used it, for example, when we worked with Boolean expressions. So for example, true and false would evaluate to false. Other keywords are, for example, as, which we haven't used before yet, assert, to assert if something is true or false, break, to break out of a loop, and one keyword which we are going to learn about a bit later is how we can define a class when we're working with object-oriented programming. Kind of the opposite of break, if you will, is continue, so that we basically don't process more of the loop, but we do it again. We learned how to define a function. We can also use del to delete something from a dictionary. We learned about elif and else. And of course, there are a number of additional keywords. You can see here, for example, for loop. Of course, the if statement, import, which we used before to import a module or some capability from a module. And some logical operators, for example, not or. So these are some of the keywords that we have been using or that we will use going forward. Let's next take a look at some data types that we used before, and actually we can type them out as well. So let's open the terminal here, and what we can do first of all is that we type in Python followed by the version, and then we switch over to the Python interpreter. Now the first data type here was the Boolean data type, true Boolean value. So for example, if we type out true or false, we get back true, because in this case the logical or will of course evaluate to true if either one of these operations is true. If instead we say, for example, true and false, then we will get back false, because logical AND of course means that both sides of our Boolean operation here have to be true in order for the statement to be true. Then other types include, for example, none, which represents nothing, bytes, which stores bytes. So for example, we could use it in the context of working with text, PNGs, files, etc. Strings to store some information. So for example, X is the string hello, which we print out here. Numbers, which we use to store integers. For example, I, which is set to 100. Floats, which store decimal values. So any value which includes a dot. So 3.89, for example. Lists, which stores a list of things, also called arrays in other languages. Dictionaries, that stores a key value pair. So these are some of the common data types that we have been using or that we will be using going forward. When we are working with strings specifically, we can use some escape sequences so that we can escape certain characters. And here are some of those escape sequences. So for example, \\/ will escape the second backslash. So if we are using it as part of a print statement, for example, if we say printf, or print actually, this is escaped, like this, then we see that only one backslash is printed out because the second one is escaped. We can do the same, of course, by escaping a single quote or double quote, a backspace character, new line, tab, and other options here. And then there are some additional string formats to format something in a certain way. So for example, if you use the percent sign here followed by D, then that would be a decimal integer, not a floating point. So for instance, if we say percent %d modulo 45, that would be equal to 45. So we basically converted the number 45 into a string here, and specifically into a decimal, not into a floating point value. And we can do the same with other kinds of formats here, so there's an overview of the different options available to us. Let's take a quick look at the operators that we have been working with, or that we will be using going forward. We learned about addition, subtraction, multiplication, power of, using 2 asterisk signs. Then there's division, but there's also floor division here, and a lot of additional options, including parentheses, lists that we define with those brackets here, dictionaries where we use those curly braces, and of course a lot of other operators, including shorthand operators, for example the plus equals, which is an option that we use to directly increment a certain number. So for example, if we write out something like that, set first of all x to 5, and then instead of, for example, saying x equals x plus 3, we can instead simply say this. So it's a shorthand form of increasing a number. And we can do the same in the opposite way, of course, by writing minus equals. That will actually subtract a number. And the same is also possible for divides equals, multiplies equals, and so on and so forth. And ideally, of course, we should practice using those different operators a lot, using them in some programs and working through that. Next, let's actually learn about, let's start by reading some code to analyze it a bit further, and we can go through the code and then take a look at, for example, functions that are used and what they do, where a variable is defined and is given a value. We can take a look at if statements and while loops, and basically read through that. And to actually find some code that we want to analyze, of course, we can basically search for anything here. What might be useful is to switch over to GitHub, a repository where users can submit their own code in an open source way, and you can read also and find the code other users wrote. So here, for example, we could go ahead and, let's say, just search for Python here. And then we can see Python is displayed here, so we can see everything relating to Python as a language, because on GitHub, of course, there is code in a lot of different languages. So if we take a look at some repositories that are using Python as a language, we can, for example, take a look at TensorFlow here, which is one project. And now we can see the different folders here, the different repositories. And they are using, for example, a number of different languages, but let's take a look at Python. And here now we can see a number of Python files. We can see that because it ends in .py. And then we can simply take a look at one of them. They have some comments here on top. We can see we are importing certain functions, certain capabilities from certain modules. And then here we're defining, for example, a class, which we'll learn about later in one of the subsequent exercises. We're defining a function here. Using if statements, we're returning values. So that can be helpful to just take a look at GitHub at some of the projects and to read through the code to see how they structure the code and to get more familiar with how to read and understand code. All right, let's take a look at the study drills. So the first one is to find out what a flowchart is and to use it. So if we actually take a look at Wikipedia, we can see that a flowchart is a diagram that we use to represent some workflow or process. So here's an example. For example, we start at the beginning here. this case lamp doesn't work, and then we have certain decision points, so we can evaluate, for example, if the lamp is plugged in. If that's true, then continue with the next condition that we are checking, otherwise switch over to that particular action here, for example, plug in the lamp, so on and so forth. And we can use that to map out our programs. So if we think back about one of the previous exercises where we took a look at the game, and we had the different options we could choose from, we could represent that using such a flowchart with the different decision points where we say which room we want to go to, and then based on that we printed out different statements. So that's basically what flowcharts are and how we could work with them. And in general, it can be very helpful to, when we write out code, to either write it on paper or alternatively to put comments above any of the code lines, and then to really think about what the different statements do to better understand it and break down the code. And of course, if we take a look at any code we are reading, if you're finding any errors, then we should try to fix them and send the author the changes. That is really easy here with GitHub, where we could basically add a comment or open a pull request, which could then be worked on by the author of that particular repository. Finally, let's take a look at a common student question. So how would I search for these things online? For example, if we are looking for some code for the current Python version, how should we go about it? And then we can simply put in the current Python version. So for example, Python 3.6 or the later versions, for example, Python 3.9 or just Python 3. And then afterwards we can type in the keyword we are looking for. For example, when we are looking for the yield statement, we want to find out what it actually does. We can type in Python 3 followed by yield, and that gives us typically better results if we just typed in Python and yield, because this may give us back some documentation for a previous Python version, Python 2 for instance, and that may have changed since. So it's quite important to make sure that we actually include the correct Python version that we're looking for. Okay, so that was a quick recap in exercise 37, and see you guys next time in the next video with exercise 38.